Visual regression testing is the practice of comparing what shows up in the UI, the visual state of your web application, with what you expect that state to be. It works by your setting of a baseline, that is, running a test that produces visual states, and you say, yep, that's what this page should look like. Yep, that's what this page should look like. That's setting a baseline. Each test that you run after that compares the current state with that baseline that you have set. Most comparison tools do this comparison of the two states using a pixel by pixel image comparison. Sauce Visual goes one step further by taking a snapshot of the DOM that produced the visual state for both the baseline and the newest run. What that allows us to do is give you a root cause analysis of any change that occurs. For example, we can tell you whether the change happened because an image is now a different size, or there was a change to the CSS code. What that does is make it possible to find the cause of that regression more quickly and to correct it. That way you have time to spend on the product itself. Less time is necessary for completing the visual regression testing. Sauce Visual integrates with your CI/CD tools, so you're able to see the test status there. One thing that is particularly great about Sauce Visual is the ease of comparing the states in the UI. On the left-hand side of the screen, we have links to projects. Projects within Screener or Sauce Visual are simply the top taxonomic unit that you use to organize your tests. The details for that project are here on the right side. I had already accepted a baseline, and I am testing 28 different states or views of my web application. As you can see, 26 remain unchanged from the baseline, but 2 have in fact changed. What I'm going to do now is look at all of the states so that we can see what a baseline state looks like and see what the changed states look like. So I'm just clicking on View All States here, and we can see that, first of all, the Screener UI is going to identify the viewport size that the test was run for, the browser, and the operating system. Within that, each of these categories tie to the individual tests run. This kind of organization is within your control. You can choose whatever names you like. This particular test, I'm testing what shows up when we try to log in with a locked out user. I have clicked to bring it up. There were no changes here. The state on the left side, the baseline, is identical to the state on the right, the most current test. Let's go back and look at a change state. The very next one is in the login valid user test, and I inserted some JavaScript to change the website on the fly so we can see some changes. On the left-hand side of the screen, you see what we would expect to see, different product images for Sauce Swag items and their descriptions. You can also see that all of these elements are highlighted in orange, and when I roll over an element on the left side, it's highlighted on the right side. You may also notice that every product image has been replaced with a picture of Joey from Friends, and every product description has been replaced with a brief description of Friends as well. This is going to allow me to show you how we analyze the root cause of these changes. I'm opening up the change panel. We classify changes as layout, content, style, or structure. Sauce Visual is using the Sauce Labs infrastructure, so your test can run against multiple browsers, multiple browser versions, and multiple operating systems all at the same time. You set up that parallel execution the exact same way you would for a regular Selenium automation test. Most organizations start by adding the visual snapshot capability to existing Selenium tests. I want to highlight an ability of visual regression testing to take the place of some assertions that happen in Selenium. An assertion in Selenium is a true-false value that reflects whether your web page did what you wanted it to do. In this example page, we are going through multiple steps. We are adding items to the cart. We are going to the checkout page here. Now we start to make assertions. This code is making multiple assertions. On this line, it's saying, hey, are we on the checkout page? Down here, it's like, okay, let's continue. Let's verify that we're on the proper page. And then this block of code here is verifying that the order total is what is expected, the subtotal is what is expected, and that the tax has also been properly calculated. So you can see we have a corresponding snapshot called verify totals. That's happening after all of these other verifications here. These multiple steps in Selenium to assert the value and test your checkout page, those can be replaced with one snapshot. I could delete all of this code here and still have the same functional result from comparing this snapshot to the previous one. So all of the independent steps to verify those could be replaced with this one snapshot. Best practice for visual regression testing is to use it as a tool to, of course, one, verify that unexpected changes to your UI don't give your users a bad experience. You want to mitigate that risk across all of the platforms and browsers that your users are coming from. But on top of that, you can use it to supplement your functional testing and to shortcut some of the more complex tasks in Selenium, like doing verification on all of these separate items on this order page with just the one snapshot.